Welcome, welcome, welcome. Hello, everybody, and welcome to today's Masterclass on Observability at Scale. Especially want to thank our live audience joining us today from all over the world. Thank you for being here. We're excited to have you. I am going to spend some time today with two people who I have personally learned a lot from in the last 6 months or so that I've been here. And I think you'll really find their conversation interesting because the level of depth that they bring from having lived and breathed this in everyday life is just something else. So without further ado, let's get started. Our first guest today is Chi Jin, who is the president of engineering and products here at Observe. And previously, Chi built hyperscaling infrastructure at Google. But he also spent some time at Stripe, where he was head of payments. And I often ask Chi, what was the calculation or what was the fun math that they did to figure out how many dollars did they lose for every minute of downtime at Stripe? What was it, Chi?
Thank you. I wish I can have a GPU power and calculate very quickly. The convention wisdom is we do 1.4 trillion about a year, and then you divide by all the minutes. However, actually, the real one, I'll tell you, was actually slightly different. I remember there's incidents we operate in Singapore, so we also take the currency exchange from an open source provider. So at one day, they they outputted the Singapore into US dollar conversion 100 times off. So basically, when we pay out to people, I was supposed to pay them sort of tens of dollars. It become, in some of the cases, become $100 million. So that's like every minute, you're actually losing hundreds of million dollars. So we were very scrambling to stop the payout. We called all the banks. Lucky for us, the banks are manual, and they actually said, guys, you're paying like 100 million for this small merchant. Is anything wrong? So they hold it. So we've been safe.
Oh, wow. Sounds like a funny story. It must not have been funny in the moment. And then we also have with us Jacob, who is our Chief Product Officer and co-founder at Observe. And I only learned after a few months of being here that Jacob actually has a PhD literally in efficiency at scale. So we have Dr. Jacob Liverich joining us. And Jacob also spent some time at Splunk. And I think some of the lessons that he took away from his days at Splunk have been really interesting as he's brought a different perspective to how he would build this at Observe. So Jacob, coming from Splunk, what were some of the lessons learned and what did you think of doing either same or differently at Observe?
Yeah, and maybe I'll start even a little bit before Splunk. So I spent a little bit of time at Google, around about like the 2010 timeframe. And while I was there, got exposed to, I'd say, observability at a hyperscale. And one of the tools that it used day in, day out was called Dremel. And Google's published tons about Dremel at this point. So, download the papers, go read about it. It's very, very interesting technology. But there's kind of two things that are really interesting about it is that it's predominantly a log management system, a way to do log analytics, like on a large scale, kind of analysis and queries on top of, profoundly large amounts of log data. And it found its way being used by tons of people inside of Google. I mean, tens of thousands of people like kind of used it for all sorts of different functions, whether it's developers just trying to, understand the behavior of the application, whether it's people on operations trying to understand failure modes of systems at large scale, whether it's people managing machine learning pipelines and trying to understand just like the performance of a system that they had deployed. There's all sorts of these uses for a log analytics tool. And so it's really interesting to see like just all the different kind of ways that it influenced operations and sort of analysis at a company at that scale. But then also the technology choices were super interesting. So it's a columnar analytics database at the end of the day, majors on the separation of storage and compute. So all the data is stored out in, Google file system, just sort of like very, very large amounts of data. Very, very easy operationally to bring these large Dremel clusters online to do analytics on this data. And so just kind of managing sort of all these different use cases, all these different sort of ways that you want to take advantage of that log data and sort of enable stuff like that. But Google's a little bit of a special circumstance. That's a company that has a gigantic printing press that's just spraying out money in the basement, and so they can take the time to build and develop infrastructure like that and sort of bring it to everyone internally. When I landed at Splunk, to some extent we're doing a lot of the same things. It's a big log management system. It's sort of at the, in the mid-teens, it was, one of the best that could really handle scale for large companies and handle, complicated use cases, complicated log, pipelines. It was pretty apparent that like, hey, most people in the world, they don't have that giant printing press. They don't have the ability to develop these tools in-house to manage all that data. And so it really does make sense to have a vendor to help them, to kind of have like a batteries included type of solution to do the large scale log management. And so at the time, Splunk was best in breed. But even at Splunk, we were starting to run into just sort of scaling limitations with this architecture. So it's you're dealing with tens or hundreds of terabytes of log data coming in per day. You have thousands or tens of thousands of users trying to query this data. And its architecture at the time never really did the separation of storage and compute. And so scaling it out to that use case was very, very challenging. We could see that a lot of the workloads that people were doing with Splunk were trending towards analytic style workloads, where they're kind of doing trending analysis over very high cardinality data over very large time periods. And kind of doing that over raw logs, wasn't necessarily the most efficient way to do it. And so it started to need the essence of a columnar analytic style architecture. And so, I would say, our roadmap for kind of where are we taking the Splunk technology very much, included these strategies, whether it's a separation storage and compute, using object storage as a primary data store for the data, bringing in the ability to do columnar analytics, hash partition joins, all the sort of things you need in order to do these style analytics. That was kind of what we were building at Splunk. And for what it's worth, I'm a technologist at heart. I was just happy banging out C++ code. I could do that for the rest of my life. I loved it. But just serendipitously, around about 2016, I read the SIGMOD paper that Snowflake published. And it described, in detail the architecture of Snowflake, which is this next generation, cloud native columnar analytics database. And what I saw was, wow, kind of everything that we had at Google, it's finally now available in a packaged form for the rest of the world. Everything that we had on our roadmap at Splunk is more or less represented within this piece of technology. And so what an interesting moment in time, to actually bring the technology that the hyperscalers use for large scale log management and bring it into perhaps a commercial form that's sort of batteries included that you can actually deploy for, all these different use cases at companies, not quite at hyperscale, but one step below that. And so, anyway, it was kind of just a serendipitous journey through Google, kind of seeing how you do this at hyperscale, going through Splunk, seeing kind of where the limitations of kind of the legacy architecture was going. Hey, maybe there's an opportunity to do this, again, in present time.
That is super interesting. I think the separation of storage compute, the things you're saying about, wait, what does a columnar store give you, makes a lot of sense. But I spent 7 years working on an indexing database, and my understanding back then, and it's changed now, but back then I always thought data lakes, man, like they sound great, they're great for scale, great for volume, but can you really do real-time ingest on this thing? Can it really handle streaming data? Can it handle the kind of query concurrency that you need when at the moment, a lot of engineers are trying to figure out what's going on? So there seems to be like some sort of cognitive dissonance there. How did you make that work?
Absolutely. Yeah, no, it's just one of these somewhat unintuitive things that happens at this larger scale. So yeah, suppose you're storing the data at rest in object storage. You don't really want to do point, reads and writes, random reads and writes on object storage. That doesn't make sense at all. It'd be terribly inefficient. It'd be expensive. It wouldn't work. However, when you're dealing with a large scale log management, situation, or large scale, trace ingest, large scale metrics ingest, I think what people often underestimate is like the rate at which this data is coming in. So when you're talking about like terabytes of data per day or tens of terabytes of data per day, you are talking about tens or hundreds of megabytes per second of data. And it turns out if you want to use object storage effectively, really the main trick is to have a good batch size. So long as you can like batch data up in sort of like this, 10, maybe up to 100 megabyte per, blob, and you can write that out to object storage, then you can make the economics of object storage work out really, really well. And the throughput through object storage is phenomenal. And so really just the question is like, well, how long does it take to accumulate that 10 to 100 megs of data? And at these larger use cases where it's terabytes of log data per day or tens of terabytes of log data per day, it only takes a few seconds to accumulate that data. And so all of the conventional wisdom about like, oh, it's slow to go to object storage, or it's inefficient to use a columnar database for this use case. At this scale, that conventional wisdom just goes out the door. You actually can achieve good end-to-end latency, despite an object store-based architecture.
And so you're able to get that kind of latency because you're doing micro batching, you're being very, very efficient about how you bring the data in. But there's still this question around concurrency.
Mm-hmm.
How do you handle the query side of the equation?
Yeah. Well, so this is the other, there's like maybe two tricks here. So one of the beauties of the separation of storage and compute is you can just bring more compute to bear when you need it. And so a typical like shared nothing architecture where you have like storage coupled with compute, if you have an incident and you have like hundreds of users coming into the system, it's very, very easy to overwhelm that system. And it's also very hard to add more compute to it because all the storage is sort of locked into the servers that you had to begin with. And so, you'd have to go through rebalancing or other unfortunate sort of activities to actually scale out quickly. So they usually don't do that. But with the separation of storage and compute, if you sort of assume that the data is in object storage by default, you can bring compute online in the moment and just basically pull the data out of object storage. You have plenty of bandwidth to do that. So you can very, very quickly bring a ton of compute online. And so it's actually very easy to elastically handle these surges of traffic, whether it's, there's an incident, a bunch of people need to query it, or a surge of traffic, and you need to write all of it out. All these things end up being much easier to handle. But then there's another trick. You mentioned micro batching. I think, one of the things about the design of these columnar analytics databases is they tend to be designed for reporting use cases, where you run a single query over a profoundly large amount of data and you're computing some aggregate, and you're okay waiting 10 minutes for an answer because you're doing a monthly report or something like that. In order to make it work for this use case, for like a real-time operational use case, you can't really do it that way. You can't really just assume that you're going to run one query, right, and expect a user is going to wait for it. And so the trick is actually to take queries and just sort of break them up. And so anytime that we actually do, say, a log search query or something like that, we're actually taking whatever the user intent was, searching for this keyword over some large amount of time. And we actually break it into tons of different queries. We'll run them, in some cases concurrently. We'll run them sequentially, kind of whatever makes the most sense to give a user an answer very, very quickly. And so for the operational needs, they get an answer very fast. For kind of large scale analytic needs, well, we still can bring, sort of this big parallel, computing engine to bear. So we can kind of handle a blend of these use cases, despite it being this analytics database.
That's fascinating. You're almost talking about taking this distributed computing system and then building another layer of distributed computing on top, just to make it work for this use case. That's a very interesting trick indeed. But what I found is we're talking about efficiency at scale. The thing that you can solve at the architectural level is very different. So even if you do all of these things, somehow you make it work for your use case. Ultimately, when you're working at scale, it comes down to how are you organizing your teams, not just organizing your data. So, Chi, I want to go to you. You often talk about, people, you care deeply about people, but you also care about metrics and operational efficiency at a level that I think people from Google and Stripe will relate to. It's almost a discipline. How do you think about this? And what have you done to set up teams for success when they're operating in a very distributed fashion in a very complex environment?
Yeah, thank you for the question. I think both sort of in Stripe, Google, sort of operate very large systems. Both are very reliable, right? So I actually worked in Google search as well as I was at one point also running the entire Google data centers provisioning and resource management for the entire Google at that time. So that's one part of the equation. That's a very large scale, consumer grade stuff. The other thing is Stripe was very complex money flow. The system itself wasn't that big, but the impact is so huge. So it's a different style. So the first thing you start is actually, you do need the tool. The tool is essentially give you the insight. So I'll basically saying, there's a period you would say, okay, we should dumb down the software engineering to be very simple thing. What you are offering a service to our customer. So put aside all the technical thing, you should just ask, here's a box. What did you give to the customer? So at the end of the day, you can measure that, right? It could be how fast the data is updated, how fresh, how quick the query, what exactly the money was delivered. So that's the metrics from the user point of view. Then below that, that's your own services, right? Which is what microservice is running, what's request, response, all the different things, and then an architecture. So in both sort of Google and Stripe, for every team who operate these things, as well as operate the product, they all have a live dashboard, right? So the live dashboard basically have this 3 level: the business level, the service level, the infrastructure level. Everyone would run their thing, and then we have a rule that we will have a weekly operating meeting. The rule is such that you are never allowed to bring slides. It's always live, and then if the dashboard is not up, means your system's up. So that was actually a serious thing. Back in Stripe, we had this thing that Patrick Collison, who's our CEO, operate this thing. It's called there's a spinner. If you get a spin, you've been put in front of him, he will just ask you all these things. So so now once you have this thing, then you have 2 sides. Before you come in, it's actually very practical. In the design, you basically say, okay, for all my things I want to achieve for the customer, what was the thing is going to alter that? And that actually make the thing very crisp, because people will say, oh, this is going to scale. That's not the question. It's like, look, right now, you're scaled at 1,000 per second in the 70% utilization in a 2% error rate. Okay, with 0.1% error rate. If you say you're going to scale the thing, what would that number be? Because then you would actually make a design much more concrete. And then obviously you're going to design and code the thing. Before that, both Stripe and Google have this practice called PRR, Product Readiness Review. I guess I pilot this thing in Stripe. So I basically have 30 questions, and you've been asked, did you run your system test? Have them all passed? Did you check your parameter? All that stuff. And one of the profound thing we ask everyone to do on the system thing is, before you launch, you must show 2 weeks of stable things you meet the SLA. If you do not, we're not going to take your, like, it would work as an answer. It's like, show me that green line. If you're not launching. So these things are organizationally, you ingest this into people's mind, right? Because a lot of people like doing features, my main thing, running an operation is not. The truth is reverse. You earn money by running the operation to make the work. You don't really earn money by doing your features. So it's actually very important, the system running. After that, obviously, then you would have phases where, system would fail, and then you would build a process of alerting, you would build a process of incident management, and you do actually have a build process of post-mortem and follow up with these things. And then if you're lucky, it's all good. If you're not lucky, then the system would have been put into code yellow. The way, again, a similar process. I guess I probably contributed to this Stripe process because I brought the Google one. The process in Google is called 3 silver bullets. So what it does is, you have an SLA, you can violate and have incidents, but once you cross certain level, the SRE team will say, your feature risk being freeze. That's it. You can no longer release any features. The team being put into the code yellow for 3 months to repair this whole thing. However, obviously you're going to serve a customer. The SVP have 3 silver bullets for the quarter to say, I do need this feature to come out. I'm going to use my silver bullet. Other than that, you're freeze. So that's the cultural thing, right? So I actually brought the same thing with Stripe. I was like, listen, if you are continue sort of payment, continue below the same, or just say, okay, we take out the roadmap and put it in the war room, and you guys do the same for a month or two, and only your green can come out of it. So that whole thing basically put reliability at the forefront of the engineering control. So
I love that. So you're almost saying that every team kind of owns its own destiny and has to manage its service, manage their metrics, and they are responsible. But look, you're talking about such a complex environment. There are many teams, many different services. What do you do when you almost don't know which is the team? Because yes, you have all these metrics, but then when there is an outage, in that moment, there's a lot of firefighting happening, a lot of teams getting on the call, trying to figure out what's the root cause, what's going on.
Yeah.
How do you think about, optimizing for that?
Yeah. There was actually two very different answers. Back in Google, I was actually also doing the Google search. The way it goes over there is obviously Google is very service oriented and everything was a real service. And then beyond that, every service have a very strong SLA like 4.9 or 5.9. So now when you have that environment, the interesting that we're actually running the search consuming side, right? So basically it's like the last mile. We actually didn't really have much of a problem. Like once a quarter, I might have an incident. And actually, we also have a joke. Like we basically, if you are running, like if you, it's called topic server, knowledge graph search server. If you are on call, we essentially everyone want on call because it's a free money. So Google pay 15%. So you didn't hear from me, but pay X percent more if you're on call. So everyone was like, I want to be on call. And actually in the holiday, people say, hey, listen, I have some other thing. Can you take my on call? There are a lot of people volunteer because it's almost nothing, right? The main reason is every component is so reliable such that the failure rate was actually quite low. So that's one way to solve it. Now, obviously, there's a lot of, it's a homogeneous design structure. It have SRE behind it. Another joke, like we were running on top of Spanner in one portion. It was really cool, and we never really talked to SRE, but they keep on bothering us because we have a test database. We keep on bringing a lot of workload on it, and it sort of failed their SLA. And they're just hotly chasing us. They're like, can you tell us early, whatever. We're like, hey, dude, it's a test base, chill. But they're like, no, this is our SLA. You impact our number, okay? This is not cool. So we have to muted our test databases. Now with the Stripe, it's a complete different beast. Stripe actually had a 5.9.5, I believe. Right now they may be close to 6.9, but below it, it actually runs on lots and lots of different payment systems across the world. They're actually not reliable. Some of them are systematically a period of time, the DNS will fail. We almost know that, right? So now you have a real problem because the thing would randomly fail in a different place we couldn't expect. So we actually built all the defense, but we have a very sophisticated incident management system. Basically, what happens is every incident happens, we have a reliability team. There's a guy just running the incidents. He will update the thing it's called SITREP, situation representation. It will always here's the situation, here's the impact, here's what people are doing this, and we'll come back in 30 minutes. And so now if you have 10 different threads, we're actually very organized. As soon as that happens, you basically have a thread. This is external communication. This is the guy who's going to communicate to internally, send email to Patrick and everyone, to the entire company, by the way, if it's a severe, and then you have an email sending every hour. This is the thread people are debugging. There's two other thread on impact. So basically what we're going to do is we create micro incidents for each of them and say, okay, you guys are going to run this thread. Every 30 minutes, come back, report to this thing. And then it was a very military. There's one guy, which is running the incident commander. As soon as he took it over, even let's say our CTO will come join us, right? He will actually ask permission. He's like, so is it okay we do this? So, but it was very, very structured, and we actually handle incidents, a period of time, and then ultimately this also win a lot of praise because every time we have incidents, we actually got people on the Twitter and praise us saying, oh, we really trust Stripe because look, even when they had incidents, it's handled so well. But that's sort of the other way, which is how do you organize these things?
Yeah. Oh my God, distributed systems thinking literally applied to teams. That micro incidents roll up to like somebody who's orchestrating the whole thing. That's amazing. You know, the thing that you touched upon very briefly in passing, you talked about knowledge graph, right? The obvious problem when you have these very complicated systems is context. We talked about architecture and frameworks and operating principles, but more and more as we talk to the larger enterprises, we find that context is the next bottleneck. Even if you figure out how to structure your data, how to store your data, how to do all of these things and get the volume under control, get the cost under control, boy, oh boy, is context a problem. And I think, Jacob, you've talked a lot about, especially, some of our customers, how they've brought some of the business context, how they think about business entities, and how they correlate what's happening at any point in time. Can you talk us through like your perspective on context in these scenarios?
Yeah, absolutely. It's kind of interesting, with observability, software, people often talk about logs, metrics, and traces. But to some extent, that's sort of the raw ore. But at the end of the day, I don't tend to really have questions about my logs. I mean, sure, I go and search my logs, or I do analytics on my logs, or I build dashboards out of my metrics. I'm looking at distributed traces. That all makes sense. But at the end of the day, I'm doing that in service of something else. I think listening to Chi describe the situation at Stripe, it's kind of all these different payment providers. Kind of when something goes wrong, it's usually as a result of like one of those particular payment providers who may have had an issue with the integration with it or something like that. Maybe a lot of the other just sort of core runtime concerns about the software stack are kind of handled. We've sort of like, we've used this, deployed this software long enough, we've operated long enough that we've kind of got that under control. It's these like third-party integrations where things go wrong. And that's kind of what we tend to notice with a lot of our customers that are at a larger scale. There's something unique about their business that is now the thing that is challenging to like reconcile or troubleshoot or sort of understand. And I kind of early on when we were kind of thinking about sort of the use cases that we could just bring value to, what are the unmet needs at scale? We're thinking about, well, what do the APM vendors do? The application performance monitoring vendors do? They had very, very good on the rails experiences for troubleshooting, typical application servers. It's sort of like, okay, so I'm having latency in my application server. Like first thing I want to know is it my code or is it the database? And so the whole way that the data is organized, the whole way user experience is organized was to like provide that context to help you navigate through challenge issues like that, and to identify like kind of what might be the root cause. But in larger organizations, it's like, well, you've kind of probably handled a lot of those issues. You probably like have the operational rigor to like run your database, reliably, to detect performance regressions before you get to production, all that sort of stuff. And so now it's like, well, these unknown sort of issues that show up, there's like a customer that's filed a critical support ticket. And now I need to know everything about that customer's experience. Or there's this third-party integration that is throwing errors. I need to know everything about that third-party integration. And so, really, that's kind of where the new challenge emerges at scale. Kind of when people design their operations, it's really around trying to hey, someone is responsible for that integration. We need to bring that subject matter expertise to bear to solve that problem. And so, we've just been, thinking about that in terms of, how do we help customers address those needs? It's really about taking a lot of this like raw telemetry that they have, whether it's the logs, metrics, or traces or whatever, and just pulling all of that context out of that data, elevating it as first-class concepts that are easy to, sort of double-click and navigate around, making sure that it facilitates sort of that workflow that's custom to that business context when they're often troubleshooting. And so whether that's like kind of the end-to-end customer journey in a mobile application, we have IP telephony customers, it's sort of like, they have, tons and tons of logs from all these calls that they handle. But at the end of the day, we're trying to understand like the life or the experience throughout this whole call, which may have lasted for 2 hours. And so like, I need to find everything out about that call. We have logistics providers that have integrations with all sorts of third-party shipping providers, and they need to understand, kind of the disposition of a package, no matter which provider it may have gone through. And so it's really just taking the kind of all the raw, API and operational telemetry they have and trying to elevate it so they can answer questions like that. That's sort of what seems to help humans troubleshoot faster. It helps these teams communicate with each other more effectively. And coincidentally, this is the context that happens to make it much, much more easy for LLMs to understand the data that they're looking at. And so serendipitously, it was sort of the right solution given where the technology is going today.
Yeah, that is fascinating. I mean, you talked about knowledge graphs, at Google way back when, and today we're talking about knowledge graphs in the context of telemetry. What I find really interesting is you can talk about entities and correlation, and you can say, well, let's make sure that you don't have data silos. Let's make sure that you're actually able to correlate. But there's another school of thought where you can say, well, if you think about, back in the day, my experience as a consumer with Google search was I would just search and get an answer. But with ChatGPT, it can help correlate and give me context. So I like that experience more. But can AI just handle that? Can I just push all the complexity down, let my systems be as complex and as siloed as they need to be, and just have an AI SRE that carries all the context and helps me with all of this? Like, gee, you spent a lot of time thinking about this and working on this. We have our own AI SRE, but you have a perspective on how AI SREs operate and what does this new world look like?
Yeah, it's a great question, actually. In some way, I really agree with what Jacob said, right? So, I mean, in some way, AI is more behave like human. So for human to really behave very well, it's actually the context really matter, because you can make a decision while you absorb information. So I actually, before I answer your question, I would actually start with maybe even the story, like people keep on asking, like, why would you join Observe? Because look, you seem to be a search dude, and then you want to payments, and all of a sudden you're doing like observability. Why? So I can give you a little bit story, actually answer your context question. So back in Google, I built this thing called an InfoStore. What it does is it's actually a Dremel-based assistant. It took all the jobs from running on every machine, every period of time, and we sucked the whole thing into a giant Dremel database. At that time, it was like 15 petabytes with tens of thousands of people running it. And so it runs the entire Google Resource Manager on top of the thing. So every job you can find out what is running, how much you consume, all that kind of things. At that time, we had all the dimension attached, which is context, which is who owns the job. Is it YouTube? Which data center? For what purpose, right? So then we can actually say, all right, for YouTube, for these sets of things, this is not efficient. So it was taken given. I never actually thought about it. And then, as you mentioned, the search. When you search, if you ask a question, for example, you will say, a famous question, hello, Adele. So what does that mean? You want a song, hello, from Adele. How would you know hello is a song, Adele is a singer? The way it does is we build a knowledge graph. Is say, it actually has all the information. When Google doing the same, it will go match the same, give it to AI, then you can say, oh, there's a bunch of interpretation, right, from there. So that's all from given. And I want to Stripe, and there are all the payments. Immediately, because we have the best tool, right? We're using Splunk. If it's a reputable tool, I wouldn't say best. I think we're better than them at this point. But we have Splunk. We have all the other things. And what happened really in these incidents is always like people say, hey, listen, payment's down. I was like, what are you talking about? Like the 4 nines? They're like, no, payment is done. Like, okay, what? So like, what? We know there's some failure. So then people actually go to Mongo. They run some Ruby code. They're like, oh, gee, it was in Canada. It was this customer. It was this credit card. I was like, oh, I know. This guy's doing 3DS testing. Turn off that flag. That's about it. I was like, so immediately save the situation, right? the other cases we also had similarly for similar thing is again the same thing, like the same question. People are saying, okay, is your 5.9? The thing about 5.9 or 6.9 is not only for the whole system, but for every customer. For all our top 100 customers, we have built a dashboard for every region, for every customer, for every payment card. We will try to get to 9. So there's some absurd situation, like Amazon was doing some stuff in Poland. They failed like 3 times in the whole day. They're like, you violating our agreement, so we have to hunt it down. So, but now, and then the immediate what I found is Splunk cannot pull all these dimensions into it. So now I have a real problem. I'm facing either I doing Splunk and search, if I couldn't find it, I have to do Mongo, or I export the thing into some sort of a repository, run reporting, which is 15 minutes late. So I have to pick one of them, right? So I was like, this is ridiculous, because I remember back in Google, I had this info store, I got everything, right? And then that's one. The other thing is you go to metrics, you'll be like, all right, fine, let's put in the metrics. But the metrics, if you have millions of customers, you have 100 regions, you have 50 different cards, you have different other parameter. Boom, the whole metrics is blown off, right? People are like, wait, you cannot do that. So I was frustrated. So so obviously we did a lot of principle, all this organization, except information is lacking, right? I have to like call people in writing Ruby code. So when I left the Stripe, tried looking for a small company, I ran into this guy. He was telling me this, what they're doing on this stuff. I was like, oh my God, this is great. So let me join. Maybe I can teach you a few tricks as well. Let's see if we can get the Google experience to everyone. So that's the thing. Now with AI, it's actually more profound. First of all, the problem with all this context is you actually need to ask. So as a developer, often you have to say, am I looking at the different country? Sometimes you don't even know. With LLM, it's actually very good because it actually can test these things, right? It actually can find this information. And that actually can run multiple. So I think feeding this into the LLM will be very smart. By the way, just advertisement, we're building a thing called AI SRE. The AI SRE essentially took all the context we built. So you could ask its question like, hey, something was wrong. You will say, well, for this customer in this region, you have some problem. The other thing I was going to also advertise with another interesting story, if you want to hear that, is, again, back in Google, even in the Google, the Dremel thing couldn't solve that problem. So that's another dream I had. Back in the days, we were running knowledge graph for MBA, right? So it always works. Score is always there, except the final. The score didn't show up after 5 minutes, right? So I got all the VP calling me. I was actually watching NBA. They're calling me. They're like, do you know like the scores there? I was like, I asked them to watch TV. They're like, no, I'm talking about it. Just go fix your thing. So we called incidents. I've like come in our room and find out the TV actually had a score and that one didn't have it. So we have basically the knowledge graph have 2 clusters. So my team was eagerly talking fair over the cluster, and they're going to be 15 minutes downtime, and they would try to ask me to choose. Can you not show the score for 15 minutes? And then they're always going to be cool, right? I was like, no. So what happened is we have been operating this for a while. We're like, okay, is there any job running on that thing impact that? Because that's a real-time thing. We find out someone was running a large experimentation. They suck all the CPUs. So we basically pause that whole thing, and then everything just went through. So that's another thing the AI can learn. Basically, we have done this thing many, many times. If we can give the knowledge to AI saying, hey, look, if the MBA score didn't come, it's a real time, go like suppressing those things. So that's another thing we want to build. I think we're in the process of building in our AI SE. So the context of, where this environment existed, what is the relationship with different programs, and the AI can suck in the brain and then try to do the same thing the human can do in this high-stake incidents. So yeah.
Super interesting. So almost saying, well, the known issues, well, humans already have that context. It's very easy to give it to the AI, but it's the unknowns that are harder. And if you optimize the system for humans to be able to handle the unknowns, well, AI can actually do that really well. So optimize for humans first is almost the underlying principle there. But I want to switch gears for a little bit here. And I want to actually, tell our live audience that after this last segment, we're going to talk to you about any questions that you might have. So this is a good time. If you have questions, please go ahead and put them in the chat, and we'll take live questions here. But I want to switch gears a little bit because we're talking about AI and humans, and ultimately the biggest thing that teams struggle with at scale, the big company problem, as we call it, is velocity, right? Complexity, volume slows everybody and everything down. And in today's day and age, the thing we care most about is speed. How do we keep velocity in the team? And Jacob, I want to ask you this because the other day we had one of our customers, an architect from Capital One, telling us how much they care about velocity at their scale. And the thing that they've found being a big unlock for their developers is actually standardization. That was kind of an aha moment for me. I would not have thought standardization and open standards help with developer velocity. You've been a big advocate for open standards. Tell us more about how you've thought about OTel and Iceberg in this context.
Yeah, right on. Yeah, definitely. At large scale, it's you have lots of different teams. You have companies that have grown through acquisition. There's just kind of lots of technologies floating around, and so it can be very, very challenging to just arrive at this one moment in time where like everyone has all their data in one place and it's all perfect and everyone knows everything that's going on. It actually just organically just doesn't really happen that way. And so, yeah, so that ends up being a drag for senior leaders at large companies. We hear it all the time. And so I'd say, open telemetry is a really interesting thing in the zeitgeist right now. It's sort of this realization that, yeah, we're never all going to be on one platform or another platform. We're not all going to just be like totally aligned and sort of have data everywhere. But if there's an interchange format, basically, there's something that we can all steer towards that we can send, to this place or that place, then maybe that's a stepping stone to getting to a better place. And I think one of the really interesting things that OpenTelemetry is doing, like in addition to having open source SDKs for application instrumentation, open source, collector, so you kind of have just sort of a vendor neutral agent that everyone can deploy and sort of send data to wherever they want to. I think that this development of what they call the semantic conventions, I think is a very, very good direction to go. In particular, if I want to know, what operating system, that like this application is running on, or if I want to know which database this application is communicating with, the OpenTelemetry semantic conventions sort of define just sort of standard ways to represent that in telemetry. And so when you think about portability of data in the future, if you sort of conform to this semantic convention, then it stands to reason, like kind of you can send that data anywhere and be able to, actually get a fast time to value for basic use cases like database monitoring and infrastructure monitoring and stuff like that. So I think that's a very, very good direction to go. I think one of the things to just note, and it's kind of, you've probably heard this in the conversation with us, so far, is that a lot of the things that are really, kind of novel about observability challenges at scale are the things that are unique to one's own business. And so you can't really just stop right at the semantic conventions. You kind of in your own sort of software engineering practice and sort of observability practice have to think about, well, what are the core things that we need to monitor? What are the sort of attributes that we should define in our own telemetry that we can all agree on and steer towards? And unfortunately, OpenTelemetry sort of it's extensible in this way. It's just you can put attributes into the telemetry data. All I'm saying is make sure that you kind of have your own internal sort of guideline documents on like sort of describing, here is how we represent our own customers, or here's how we represent our own integrations. So that's all well and good for the instrumentation, the telemetry, and sort of sending it to a destination. But I think the other unfortunate challenge that people face these days is, if I send the data to Splunk, or I send it to wherever, like, it's sort of now it's kind of locked away in Splunk, and it's locked away somewhere. Like if I have other use cases for that data, it may be hard to get at it. if it's all well and good if my application developers can search the logs here, but hey, maybe I have a support team that's also having to handle sort of inquiries from customers, and they need to be able to get those logs. Or I'm trying to build some data products or some machine learning pipeline. Well, they might want to look at the application data to understand what activities are users doing in the system. And so there's just all sorts of like different uses for this data. And so I think that the next shoe to drop in all of this is really kind of embracing a more standardized sort of data lake, practice within these large organizations, where rather than siloing the data away into the observability vendor, you'd actually rather have that data end up in a data lake in sort of open formats where anyone can query it, anyone can go at it with the tool of their choice to perform their job function. And if the tool can come to the data to perform its function, that's so much easier to reason about than having to make a bunch of different copies of the data and sort of have to tell everyone, well, if you want this thing, go to this place. If you want that thing, go to that place. If you can kind of just have like one trusted repository for all this data, it makes it easier to answer questions like that, easier to sort of enact these new use cases on top of it. So that's the way we've been thinking about it.
That makes a lot of sense. You're basically saying, well, with something like Iceberg, we're all speaking the same language. And well, you can use a query engine of choice, but you can also use it for the use case that you need. That makes so much sense. But, Chi, I want to ask you something related but different, which is when we talk about developers having, access to all of this data, that's all well and good. But the biggest thing we hear about is developers getting interrupted all the time, right? You think about velocity. You want developers to, well, of course, have access to the data in a standard way, have all the context they need. But wait, like they have a certain way of working, and well, they live in their IDEs. The thing we often hear is they're getting lost in a sea of dashboards or trying to figure this out. And I know you've been thinking very deeply about AI and Cursor and code gen and how developers can now start, using AI in the way they're already working to not just write code, but also, get production reliability. Talk us through your line of thought there.
Yeah, well, thank you. One thing I feel like, so we're engineers, we often produce tools for other people to use. If you think about like data warehousing and AI, right? For the customer department or for the sales department, they actually have a very good data warehouse, have analytical tools. And then you kind of go back to engineering. Like I would actually challenge any sort of engineering organization. Think about when did you actually get your own data warehouse? Think about when did you actually get your analytical tool to help you do your job? Actually, none. Which is in some way was a little bit absurd, because if you think about it, for all the digital economy, half of your OPEX cost, half of your people cost is probably people. So well, why wouldn't we treat them well, right? And part of the reason is because all the structure, all the data is quite unstructured, quite messy, the process is messy. So here comes rescue. One is like, I think this whole concept of iceberg and log with context, which give you a foundation of the data. But there's a few things missing. One is the production of the data, like how we produce this thing was very poorly constructed, because everyone just write a log line, write their naming of the metrics. So this problem can be solved by standardization, just like Salesforce standardized CRM. Actually, citing my Google example, again, like I actually like, I don't remember I ever run into that problem. Part of the reason is there a standard log format, standard naming convention, and standard middleware in Google. We never had that problem. So now with open telemetry, it's excellent. No, we could do that. But one thing we find out is, again, developers busy writing code. The last thing they want to do is try to figure out where a line they should insert a span or not, right? It's just part of their flow. So the idea is if we have code gen tools, you can look at your code and figure out where I can insert these statement instrument, and cheaply, and in a not too much, not too little, that will be totally like take out the trough on development. So code instrumentation as part of observability, right? I think again, like we're working on a thing called Oli.ai, which will actually allow you to send us a code or connect to your coding tool, or being able to generate this instrumentation for you. So take out the trough. The second thing is, once you got these things, when you had a data, a lot of people, like at least observability vendor, they sort of insert themselves into every engineer, right? As if like, this is also another thing I found it very interesting. Sort of, at least in Google, you don't get teach too much about these things. It's just part of life. It's not a big deal. Outside, it's like observability is such a big deal. It was like in your face. You have to like learn all that stuff because there's too many dashboards and too much saying like it's almost like observability become part of your life. Instead, I think the observer should be behind, should be just building. Basically, will handle the alert for you most of the time. You will get a wake up once a quarter. That's probably earth-shaking events. Majority of the time, we'll take care of the thing. So the AI should be able to read the alerts and try to triage and figure out all the noises and take care of the thing for you. So that's another thing. I think it's more like automated AI triage for the less. And then when you need it to bring human in, right? And then lastly is if we take care of all that thing, that means we almost achieve the ability. And that actually goes to the third one. I feel that observability should be able to bring insight how your customer are using your stuff. Another example, like back in Stripe, we'll try to give people instant payout. We don't have a whole lot of people taking on this thing, so we couldn't figure out why. When you really look at it, it's because if you have a button on our app, you say, hey, you pay out to yourself, you got a lot of people want to use it. So these type of thing is the third level, which is observability of your customer behavior, and then you can optimize, you can do AI. I think AI can do that too, which is saying, okay, just watch people's behavior till it's saying, hey, listen, this particular UI saying, actually nobody click on that. Would you mind like change it? So ideally the AI will be in your entire demand phase. You basically have your assistant, have your data warehouse do that, right? I will close that by, I think something Jensen Wang said in one of his interviews, I saw it really resonating. Because a lot of people worry about AI is going to take away job, all that kind of things. I think in certain way, the way I think about software engineers, in the very early day, you wield one CPU, one computer. Okay, you only deal with that thing, it's a local. Now you go to cloud, you can run hundreds of CPUs. With GPU, all the thing, now you do the millions. So basically, how much computing you can run makes your scale, makes you efficient. I think that's the goal. We will hopefully will contribute our whole part of it. Yeah.
That is super interesting. I have one last question for you, Chi, and then we'll take questions from the audience. You talked a lot about productivity, velocity, but ultimately, the thing that I've seen, this is my personal experience, is, being on call is really stressful. There's an element of developer, not just productivity, but happiness here. Do you see AI actually making developers happier?
Yeah, I mean, I think as sort of a VP engineering type of guy, right? So what do you normally worry about? People often say, hey, you worry about, customer unhappy. Sure. You worry about your computing costs. You worry about feature velocity. There's something people never say, which is, if you really run these large teams, it's really the on-call workload. In fact, that's probably the number one reason people attrit. So I think what I actually find out is, and then people say, oh, nobody wants to do on-call. It's actually not true. Because when you do on-call, when you have a major incident, you solve it, you have a huge amount of like satisfaction, right? But what you didn't want to do is you get waked up, it was some like small noises or some false alarm. So people get very frustrated. And so, or if you could wake up 3 times, they're more frustrated. So, and I think the main thing is, how can you get this 95% thing being handled by AI? But when you needed a critical decision, it bring you in and give you the information. And that way your team will be very, very happy. And it's sort of a head of bench. You'll be like, okay, nobody's quitting because of on-call. In fact, they love the on-call because they solve customer problems.
That is really profound. You're almost saying, well, it's very high impact work. And the reason people don't like doing it is it's extremely stressful and messy today. But if we can take that stress away, people will not only want to do the high impact work, they actually feel good about it. And ultimately, that makes for happier teams. Well, on that note, thank you so much, Chi, Jacob. I'm going to take some questions from the audience. Let's see what questions we have coming in. Please use the chat window. I have one from here. This is from Arvind. this is very specific to Observe, so I'll probably direct this to Jacob. How is the Observe tool different from other tools in the market? Can it actually combine logs, metrics, and traces from different sources, or what is it actually doing to map the underlying resources here?
Yeah, great question. So the answer is yes, we do combine all of these into the same operational data store. Sort of one of our observations, actually is something I took away from Dremel, is that a lot of this data, it's all just semi-structured time series data, whether we're talking about logs, metrics, traces, it's all kind of fairly similar. It tends to be kind of nested data, and so, but anyway, you kind of squint at it, it all more or less looks the same. You have a timestamp. You may have some string fields in it. You probably have some numeric fields. You have a bunch of labels that describe where it came from. A lot of this data is very, very similar. And it turns out our operational data store, and we store a lot of this data in Snowflake, it's very, very good at handling that type of data. It will on its own go ahead and columnarize all that nested semi-structured data and make it very amenable for whether it's a log search query or a metrics query. It does all those things quite well and kind of puts it all in the same place. And so it's very, very easy for us to correlate that data and to convert from one data type to another. All this sort of things are just sort of natural, given a sort of building on top of an analytics database like that. But then the other kind of trick here is actually it's very, very simple. So how do you make this data contextualized? How do you make it navigable? How do you actually organize it so that you can go from like a metric to a related log? And in many cases, the trick is very, very simple. Just treat it like a relational database problem. Basically, you have correlation keys within this data. These can be used to establish foreign key relationships from one table to another. And it's no more complicated than that to get from one piece of data to another. The one thing that we do to make that experience a little bit more natural and I would say a little bit more powerful than what you typically see if you're just dealing with the raw data telemetry. In addition to having the raw logs and having the raw metrics and the raw distributed tracing data within our platform, we also build what we call reference tables or resource tables that are sort of like, I'd say, the inventory of the entities in the system. And we'll derive those tables from the raw operational data. So you sort of have effectively like a live configuration management database of your whole system. And so when we define these foreign key relationships, we tend to do them through one of those reference tables or resource tables. And so now I have sort of a log and it's talking about this user, and I have a trace and it's talking about this user. And so that user ends up being the pivot point between all of this different data. And then that makes it convenient because now I have this user table and I can have all the attributes about that user. When was that user created? When did they last change their password? What category of user is it? Is it a free user or a paid user? It's kind of all the types of data can be put there. And so you can have it at your fingertips whenever you're looking at a log. You can sort of double click on that user and sort of see all of the related data about it. I think through this whole conversation, we've been talking about the challenges at scale. And it's kind of one thing to do this for kind of the standard cookie cutter infrastructure building blocks in a runtime environment, whether it's the database or the cloud provider or something like that. But when we start talking about your specific business, sort of like, your concept of a user or your concept of a transaction or whatever it is, when we can build these views that like very, kind of bring in the attributes that are very specific to your business, that's what makes it a little bit different. That's what it makes it easier to navigate the data and understand. When I see this user ID, here's what that means. It's a little bit different than what you see in other platforms.
Thank you for that, Jacob. And we have just a couple more minutes left, so I'm going to take one last question here, and this one is for you, Chi. The question, and I'm reading here from the audience, is, Chi, you shared a lot of interesting stories from your past example, and then you said you joined Observe because you wanted to change some of these things. Are there any customer stories or examples that come to mind that you've seen a customer using Observe and doing things differently or helped speed up incident resolution? And I'm going to take you off the hook and say you don't have to name the customer, but you can still say, here's an example of, what comes to mind for you.
Yeah, I'll give you, a kind of a simple example, right? We have a customer in the logistics. So what they tend to do is that they look at a shipment. When you look at a shipment, they would actually try to figure out like which customer, what package. These things, simple things, was actually impossible to do in their previous vendors. So their support team often just start with, okay, this particular shipment, but for which customer, they have so many fitting things. So there's an example of people using this sort of dimensionality to handle these problems. So that's sort of one concrete example. We can see that. The other thing I was gonna actually also gonna mention is a bank also use us, which I probably want to use that because it's something to do with their payments, right? So it's more sort of a business level thing. Basically, what their debugging flow is, you start some payment failure in the mobile, and then you look at which flow in the mobile, and then inside flow, you look at which applications. So the way they construct that is they basically have business level entity and then payments, and then inside that thing, it'll be like which application, and inside that thing, which is like which team. So we actually being able to construct these layers of entities. So in the top, they can actually just say, oh, you know, this mobile payments here has some problem, and you can double click and double click. And then when to the last end, their team in the triage center will say, let's call that team. It actually really helped them because previously they will basically have a bridge of hundreds of people try to like, hey, did anyone volunteer? Is what problem? Now they actually can come down to it. It's not like high tech or not. I wish I think our bot as my side project. I want to actually deploy our AI so the AI can figure it out. But for now, before that, we already had the thing working sort of in their production. We see the data to show their MTTR get reduced.
That is amazing. So thank you again, everybody, for joining us. And thank you, Chi, Jacob. This was really, really fun. I learned a lot, and I hope you did too. And that's a wrap for our masterclass today.
Right, thank you. Cheers, bye.